So I just brought up um, an example from Newton just to kind of connect it to that um, situation. So how many distinct ways are there to arrange clear marbles, green, yellow, pink? Um, and so as we're thinking about, we've got um, how many, we're going to put them in a row. I think this is actually a very difficult problem. But I want to make sure I understand the problem before I proceed. I think I'm putting them in a row. So I have three options, 6, 9, 11 different marbles in a row. And I'm trying to figure out how many different ways of arranging those there are. All right, I'm just going to dig into this because I think this is a fun problem solving activity. So I've got 3 clear marbles, 3 green, 3 yellow, pink, and we're looking for different ways. So first thing I'm going to do is abstract here, C, G, Y, P. So I have 11 marbles in a row. One of the things that I like to do when I'm solving a hard problem is kind of think about similar problems to help try to give me insight. So if I had 11 different marbles and I wanted to look at how many different ways I could arrange them, then the order matters. And so I'm looking at a permutation situation. So I would say something like permute 11, 11, because I have 11 spots for things to go in and I have 11 different marbles. All right, this is an enormous number. This is giving it to me in scientific notation. So with commas, I'm already looking at 39 million different combinations. It's going to be a smaller number because I have some repeated marbles. Like I can't tell the difference between one clear marble and another clear marble. So there's only 4 different groupings. And so the next thing I would do, this is just sort of framing my expectations. I'm going to turn this into a smaller problem with only 2 different colors and sort of think about how I would solve that problem. So I've got 3 clear marbles. I've got 2 pink marbles. How many distinct ways can I put these in a row? Okay, so that means I've got 5 marbles in a row. And now I'm trying to sort of think through, well, we really only have 2 options for my very first marble. And so it could be clear or pink. And I might start with clear. So now I'm going to just note that with the letter C. So now I have 2 more clear marbles, 2 more pink marbles. And so from that, then I can do, let's just have a what's left here. I've got CCPP. So from there, I could do C. I could either have C or P if I do C, then what's left is CPP, and this is CCP. Once I get to this situation, there's one. It's like, where does the C land? Gives me how many options are left. Okay, so let's just finish that. Then there are 3 ways to arrange that. There's 3 ways to arrange that. So I've got 2 options here. And this is sort of my larger branch, was whether I was going to start with C or P. I just need to look at the P side. Then I have 3 clear marbles and 1 pink marble. So then that breaks into C and P. But if I choose a clear marble, I'm at CCP. If I choose the pink marble again, I'm at CCC. There's only one of these. There's 3 options here. There's 2 options here. I think part of what I'm sort of struggling with is how to use Excel to do this. This is like a better tree diagram where I can start with a clear or a pink, and then from there I can have another clear or a pink, and then from there I have 3 options, which is this. That's what I was representing here. And then this one is clear or pink, and then this one has 3 options, and then this one only has 1 option. So the ends of this tells me how many different combinations I have, which is 3, 3, 3, and 1. That's 10 different ways I could arrange 3 clear marbles and 2 pink marbles. And what I'd like to do is figure out how I can go from the sort of generic 5 marbles in a row to the 3 clear and the 2 pink marbles. But I'm a little worried that I'm taking up time on a difficult problem in Newton, and I want to make sure I have a chance to answer your questions. So I'm going to stop this problem, and I'm going to give you guys a chance to ask questions, and then I'll resume the recording when we're done. And if you want to hang around and watch me solve the problem, you can do that. So, all right, let's get back to this problem. Share. Into. Okay, so I think the answer to this question is, this was a similar question. It was 10. That's my guess about what it was. And now I want to kind of reverse engineer, like I had 5 choices, but how many, but I really only have 2 types of thing to go in there, right? So it's kind of like, but it's also like unequal. There's more of this than there is of that. So it's like there's 5 slots, and I have 2 or 1 choice, depending on how my kind of selection goes. And so I'm just thinking about how to quantify that and generalize it so that I can apply it to this harder situation where I have 11 choices and I've got 4 different types of things. So one thing that occurs to me is that the first time I choose, I have 2 choices. The second time I choose, I will also have two choices. But at that point, then it diverges. So I had 2 times 2. So that's the first. So I have 4 different ways of doing the first 2 slots. And I could list them out. It's either going to be CC or CP or PC or PP. And then at this point, right, because this one is unique in the sense that if I've done the PP, then there's only the CC left. But in these, well, in this situation, well, sorry, CCC left. And so there's only one option there. And then for if I do PC, then I have this CCP, and there's 3 different ways that can be arranged. And then this is P. This is the same. There's 3 different ways that could be arranged. And this one is CPP, and there's 3 different ways that can be arranged. So that kind of affirms this idea about 10 ways of doing that. But it's not helping me pin down how to combine the 5 and the 2 and the 3. And I'm feeling like I'm just a sort of a recollection. This isn't good problem solving. Well, it's not bad problem solving. It's like, is there something about this sort of factorial 3 times factorial 2? Yes. Okay. This is interesting. And so my guess is that it would be like factorial 11 divided by factorial 3 times factorial 3 times factorial 3 times factorial 2, which is still 92,400. I'm going to pop that in and see if it's right. Ooh, mama. Yeah, that's not an easy problem. And interestingly, this sort of breakthrough was a recollection of something that happened before. I didn't actually come up with a good explanation for why I should take the factorial of the first one, but then divide it by the other 2. Although now, post haste, I can sort of come up with an explanation, which is if I have 5 distinct objects like the colors and the order matters, then I do factorial 5. And the reason I'm dividing by factorial 3, factorial 2 is because the way the 3 clear marbles can be arranged within those 3 spots that they occupy is irrelevant, and so needs to be divided out. And the way the 2 pink marbles can be arranged can be divided out. Anyways, I wanted to include that because I'm going to make that a separate video, but this is one of the problems that I personally find more challenging. And I always have to kind of think about it. And I wanted to model not just like going straight to find an equation, but trying to like work through and understand the situation and use simpler, similar as a way of approaching that. Okay, hope that helped. I'm going to stop this and head out.